Hey, so what's up and welcome back once again. So today I will be taking you through yet another project idea that I was thinking about. So for the previous one, I think I had a little bit of issues here and there, and so I had to, let's say, put a pause on that. And so I don't think I will be pursuing that with rigor as I will be doing for this one. But based on the challenges that I faced on the previous project, I will be trying to avoid those for the time being and focus solely on this one, and so that I think we're able to build the entire project. As I had alluded earlier, was that I would like to focus more on building the entire end-to-end project. So that means the initial processes, building the from the idea itself. So I will explain to you the type of project that we are going to be building. Then we start with the ETL process, building the ETL pipeline. Then from there, we build the training pipeline, the prediction pipeline. Then we deploy this model. So in the deployment phase, also consider that we will be considering also including the Kubernetes. So that process will be on our deployment end, where we'll be deploying this model to mimic a real model or a production setting. Production setting. So that means we'll set up a server, a Kubernetes server. I'll be using a mini one. Then how we are going to take the model from our test environment and do a full deployment and wire everything together so that it mimics a real production environment. So based on what I was facing in terms of challenges in the previous one, I won't be continuing with that, but just lift some of the processes that I had done earlier and then convert it into this new project and then start on this ultimately, okay? So bear with me for that. But again, we have a new one that we can actually start building. Okay. So with the new project, this will be the data. So we'll be building this project. So essentially, we'll be looking at perishable goods management. And I try to pick this from the retail sector, or I think the retail within the retail domain. And so and see how we can actually implement machine learning model or machine learning systems into such a setting, and how we can leverage those tools in actually building systems that we can use to make decisions. We can rely on those for such processes. And so this is a perishable goods management system. And as I had also spoke earlier, I think in the previous setting, is that we're not just going to build a single model. We're going to build multiple models, and with those models, we're going to see how we can orchestrate the entire system within the setting. So this won't be a simple a model that's, okay, for example, spoilage prediction, but we're going to see if we can build a spoilage prediction, a demand forecasting, and also maybe Markdown or a discount models, and see how all these models, 3 models or 4 models or even 5 models, how we can orchestrate the entire chain to build a multiple models, each having a specific objective that is covering, and how we can orchestrate the entire process in when you're building such systems. Because in production, I think you won't be deploying a single model; you'll be deploying multiple models. And so, because I'm quite familiar with the data science, a bit of it, building those ML models in a Jupyter notebook setting, and a little bit of converting that into the pipelines. So I wanted to go a little step, one step ahead, and so to actually do the deployment in Kubernetes and all that. So this is essentially what we will be covering in this model. So I think for a start, we'll start with the spoilage prediction. So generally with the description, so this data is about 100,000 synthetic records. Of course, that's the data that we have. Then this covers about 10 product categories: dairy, meat, seafood, produce, bakery, dairy, frozen meals, beverages, pharmaceuticals, and ready-to-eat items. So those are the product categories. And then from this list, you're able to see that almost all these are perishable goods. So if you're going to make orders on these products, then we need to make sure that demand is right. If you're going to offer discount, we need to make sure that the discounts that you're offering are in such a way that you're also not making losses. You also need to do the predictions, spoilage predictions, making sure that whatever quantity we are asking, we're able to ensure that they're not getting spoiled within on our shelves. Okay, then inventory management and so on. So you can see based on this use case, we're able to build multiple models, and then so the how part is now is now where I come in, and I'll make sure to take you through step by steps and how we can build such a model. So this is the data set, and I'll make sure to include the link of this data set so that in various tutorials or in various builds, we're able to track. Also, I'll also share the GitHub. I've created a Git. I think this is the GitHub. So this is the GitHub account where I'll be making sure that I commit every changes to this so that you can also have them. Okay. So today, essentially, I wanted to take you through the entire project architecture so that you're able to be familiar with essentially what you're going to be building. Okay. So the project will start like this. So we'll set up a bucket, and consider bucket to be something like not really a data lake, but bucket will contain our or will house our the raw data set. So once we get our data set, then we have to house our data set. Remember, in normal instances, you will not be having the data in your, let's say, in your workstation, your laptop, desktop, or whatever instrument or tool you're using to build these models. Data will be housed in a given database. Okay, so we have different versions or different sets of databases. So we can have a data lake, we can have a data warehouse, or any other. Okay, so for this case, we'll try to come up with a data lake where we'll be hosting this data. Then once we host our data in a data lake, we'll carry out an ETL pipeline. So the extraction, transformation, and loading. And for the ETL, for that data, we'll try to split it into, let's say, these 4 types. So we'll have, although the data is just a single set, but to try and mimic a real production environment, data won't be in a single table or in a single data set. We might have a different data sets. Okay, so to try and mimic that, I did split that data into 4 sets. So data only containing the products, data containing another table which has the stores, telemetry data, temperature, and so on. And then we have another data based on sales and inventory. Okay, so that will be the ETL process. So the ETL process will extract that data from a data lake. Then we carry on the ETL process on these 4 data sets. Then, because you are carrying out the ETL process on individual data sets, then we need to have some sort of an orchestra. And for that case, I did choose Dagster to be that orchestra. That means that will be our single entry point where we can, with a click of a button, for example, we can orchestrate the entire ETL process. So that means we're able to pick that data, do the extraction, transformation, and loading. And then for the loading, I will be using Google's BigQuery. So that will be, after we do our ETL process, we load that data to BigQuery. So BigQuery will house all our, let's say, the features after we do the transformation. Then once we have that, Dagster will be sitting on top of that entire process to actually orchestrate the entire process. So with Dagster, we're able to run our entire ETL process. Then from the Dagster, I think this is what I was explaining. So we'll have to store our data. So the features will be stored in a BigQuery. So BigQuery will be our offline store. Then Redis will be our online store. So that means when you're building this system, we have to be mindful. We'll be building for offline predictions and also for online predictions. So those are, I think these are the two types. I don't know if there's any other. That when you're building such ML systems, you have to also condition the system to work for both cases. If we don't have, let's say, internet connection, we still should be able to get predictions. And if someone wants real-time predictions, especially for such a project, perishable goods, we need to be monitoring the systems 24/7. And so we need to also have a case where we can make predictions, the online predictions, and essentially what is the best database to actually for this process. And I think Redis will be for that. So Feast, we'll be using Feast as a feature. Feast will now be sitting on top of these two types of storages. So Feast, the feature store, I think we'll also cover in depth how to set up Feast and how Feast will communicate with the BigQuery as your offline store and Redis as your online store. So how does Feast actually help us in terms of that? So Feast is an open source tool. Dagster is also an open source tool that we can use for these processes. Okay, so when you are building these, I'm also considering the different open source tools that we can actually use when you're building such a system. Okay, now once we have done we have extracted data from the data lake, we have done our ETL processes, and then we have stored those features within the respective storages. Then Feast will sit on top of those storages, and the Feast will help us to query those databases and retrieve the features that we want, especially when you are building the model. So Feast will extract those features, and the first instance generally is to do an EDA. So the EDA exploratory data analysis that will enable us to inquire more about the data. So here, essentially, what we are going to do is to look into the data and try to understand that data. What will be our understanding about the data? What are some of the correlations? What are some of the patterns existing within that data? So when we are doing our EDA processes, that will be the essential component that we will be looking into. So Feast will extract the features. EDA will be now entirely on us to actually understand those features. So from EDA, we have to perform the feature engineering and also the model experimentation. So based on the understanding of the data, although in most cases when we're doing the ETL, we try to inject the feature engineering, but that does not mean that that's the end of that process. But when we do our EDA, we also need to, when we do our EDA and push forward into feature engineering. So this will be creating more features based on our understanding of that data. And then when we create our features, we have to do the model training. So essentially, EDA, feature engineering, and the model training will be performed within our testing environment. So we create a testing environment for these entire processes, and essentially that will be our Jupyter notebook. So we'll do all this in our Jupyter notebook, and I will test a couple of models, do feature engineering, hyperparameter tuning, and all that. So we'll have a couple of models, and within those models, we will be able to do training of those models. Once we do the training, we'll start with the base model. Then base model will form as our basis for the other models. Essentially, the base model is usually the logistic regression because we are starting with the classification problem. So logistic regression will form our basis. Then we'll try other models, the tree-based, random forest, XGBoost, light boost, cut boost, or even you can go to the distance-based models, K and K nearest neighbors, decision trees, and all that. Then, based on our entire experimentation, because I think one of my supervisors actually told me that when you're building these models and you're doing your training, ensure that your Jupyter Notebook becomes like your research platform. That's where you do your research, your everything. Okay, so you have to show everything when you are doing your model training. How you're training your models, if you're using different techniques, SMART, for if you're having feature imbalance. Okay, so how do you perform the entire process? So that's like a research research platform, because once you've realized everything within the entire Jupyter Notebook, then you have to convert that work into now a deployable pipeline, and that's where we'll have to build our training pipeline. So with the training pipeline, that means we have to mimic the entire process. Okay, so we have to get that data, so data ingestion, then we have to validate that data, validation data, meaning that we'll have some sort of a schema. And that schema will contain the rules and the regulations we expect from our data. So that's the data validation phase. So the feast will also be like if you have watched American football, there is this quarterback. So feast will act as our quarterback. So it will be writing those SQL queries. Then based on those SQL queries and the instructions that we have provided, feast will go through your database and extract those features. So then we'll perform the data ingestion phase. Then after the data ingestion phase, we move to the data validation. So the data that we are having, we have to have some sort of a schema. And that schema contains the instructions that we will need that data to respect. Okay. Then it is at this data validation step where we also define the data drift. Yeah, I think data drift. So we perform some statistical measures. So this will be our original data, and we'll perform those statistical measures, and we'll show those as our baseline. So that will be handled within the data validation. Then after that, I think we'll move to, let me see. Then I think after that, we will move to the data transformation. And with the data transformation, that means that during our training, feature engineering, and all that, of course, there are some data transformation steps that we did before doing our training. So those will be replicated within the data transformation. Okay. So if there are any median calculations, mean calculations, other transformations, maybe we calculated a product between two features. Okay. So how did we do that? So all that processes will be again done within the data transformation. Okay. So data transformation, again, this is a necessary step that we actually need because we are preparing data for a model training. Okay. Then once things like one-hot encoding, label encoding, and so on will be performed under this, and also the most crucial step, which is about splitting that data into training set and the testing set. All those processes will be conducted within the data transformation. And after the data transformation, we move on to the model training. So we will train the model, and this is it will be easier for us because we've already done our entire process in the Jupyter Notebook, and from our entire research process, we're able to select what is the best model that we are going to use for this entire process. And so instead of replicating the entire process, just select the best model, or even if you want to be a little bit more technical, we can include, let's say, 3 models. So we have one model that we rely on to make predictions. And then we look at other 2 models to be like validation models, so that whenever we do the predictions, we don't have much variation, something like that. If time allows us, we'll also include that within. Then after the model training, we'll do the model evaluation. And within the model evaluation, this is where we test the suitability of our model. So for classification models, of course, we have the evaluation metrics, the ROC, the PR, precision recall. We we have the classification report, we have the confusion matrix, we have the other metrics like the Gini coefficient, the KS statistic. So all those evaluation metrics, all those metrics will be performed during the model evaluation. So where we test the suitability of the models. And if we are contented with that, then we move to the trained model, the model serving. Things like ML flow will now come in for weights and bars. You can use such of those tools to version our model, which is very important. So data versioning will be important. Again, I will talk about that when you're building the training, the training pipeline. Then the model versioning will also come into place because we have to version the data plus the model itself. Then we push that to the model registry. From the model registry, I think I was not done with this. We can now move it to now creating the prediction pipeline. Then the prediction pipeline, this is where we build the prediction pipeline and how we can deploy the entire process. Okay, so I think when it comes to such a model, I think I did borrow much from. There's this documentation from Google where it did document the different types of MLOps system, and this is the most advanced one, I think, level 2 with the CI/CD pipeline. So this essentially just borrowed much of it from this. Then I've added the ETL process. So this is what we will be building when it comes to such a model. And you can see it's quite intensive, but if you're going to build ML systems in production, this is generally what you will be building. So you'll have your feature store that will be playing as your quarterback. Then you have your ETL, your training environment, so experimentation or the development or the test environment. Then once you successfully that, you move that to the production environment. So you'll have the automated pipeline. Then you have your prediction service, performance monitoring, which is also very important. And I think I'll create another video where I will be talking about the difference between DevOps side and MLOps side and why you need a dedicated machine learning specialist when it comes to building ML systems. Okay, so there is some fundamental differences existing between the two that we actually need to be wary of when you are building such systems. So I'll look into that, and then maybe I can try to explain the difference between those two. And because ML systems, these are newer systems, and in most cases, we tend to borrow much from the DevOps side. Okay, but that's another video for another day. So for today, let's just focus more on what we will be building. So essentially, this will be the entire architecture, and don't be wary about it that it might look complicated. All these I've tried to build such, and so with proper guidance, I think we'll be able to crack this entire build. Okay, so that's what we will be building. So I just wanted for today to take you through what we'll be covering so that you have a feel of that. Then I will share with you the data itself so that again you start make sure you have your data. And then when we start the entire build, we're able to move quite fast. Okay, so then make sure you have a GitHub. So this is the GitHub. I'll also share the GitHub link for this so that everything you'll find it here. So this is just the initial Git. I'll try to populate it so that in the next video we will be having more files, folders neatly arranged. Then instead of writing the code line by line, I will just be explaining the steps that I took to get to a certain point. Okay, so for tomorrow, I think we will start on the ETL process. So we can set up a virtual environment. Then after setting that environment, we can install all the dependencies that are needed. Then after installing the dependencies, we can start on the ETL process. So there's this database, I think, no, is it S3, not a database, S3 storage. So it's called black box, black blaze, I think so, S3. Black blaze, this one. So this will be using this as our S3 compatible object storage. So all our raw data and everything will be stored within black blaze. Okay. So if it's possible, create an S3 storage. Of course, tomorrow I can show you how to create that. So you can create an S3 storage and house all our raw data. Then from the S3 storage, that's where we'll be copying that data, doing the ETL process, and then saving that data in a BigQuery. Okay. So if you can set up this, let's say tomorrow, then tomorrow we can do setting up the virtual environment. We can also install all the dependencies that we need. Then set up black blaze as an S3 storage, and also we can also set up BigQuery as our feature store. Okay, so if we do that tomorrow, I think we'll have make headway. Then in the next phase, we can start our ETL process. Okay, so I think that's it from my end today. So it was just an introduction of the next project that we are going to be working on. Forgive me for the other one, but this, I think with this one, we're able to do quite an extensive job. And so this is what I will be focusing on in building the entire end-to-end project. Okay, so I think that's it from me for today. I think we've had a lovely session, and so as you prepare your environment and everything for the commencement of the entire project, so please do so that next time we can set the ball rolling. Okay, so that's it for me today. Thank you for your time. Thank you for taking time to watch this video, and let's meet in the next one. So if you are new to this, please consider subscribing, set the notification bell so that whenever we have such sessions, you're able to be notified, and then you can join. Okay, if you have any questions, concerns, and queries, just get to the comment section. I'll try my best to get back to you, and if it's any challenge, I'll be glad to actually help you with that. So with that in mind, until next time, see you.